Okay, we're starting again. Okay. Okay, so this is part 2 and part 2 of 2, probably, the last part. Alright, so I want to cover the concept of introspection a little bit more, give you a few more details on it. Talked about it already, but it has to do with using that ID as terms of the generic object. It's not all bad. It's not that you should not use it. It's good to use it, but if you are going to use it, you need to check to see, and here's some example of the methods that you can call on objects to see, is it a kind of class? Is it a member of a class? Does it respond to a selector? If you remember, we did an introspection tutorial on this and ran all 3 of these methods on instances of objects to find out if they were buttons or labels or views or something. So an object that inherits from Nsobject has these methods just like it has a toString or string in Java. We have more methods that, is similar to what we have in Java on objects. We have more methods, however, in Objective-C than we have in the Java language. We don't get anything in C++. We don't get very much at all. Everything has to be done manually. They added a lot of stuff to Java. They added a lot of stuff to Objective-C because Objective-C has that generic pointer type. And so the object itself in the Nsobject has to have some sort of way of checking to see what it is. So returns whether or not, for example, is kind of class, returns whether or not the object itself has any type of inheritance of anything included inside of it that might be appropriate for the particular class item. Is member of class gets at which object class the class is actually from, and then response to a selector will tell you if the method actually runs on a particular object. So arguments to these methods are likely a little tricky, a bit tricky in order to remember. If you're going to use it, you're probably going to use it consistently in a certain way. So class testing, whether methods takes a class, you actually have to put in here a string class from is kind of class. So you say is kind of class and you stick in there person, employee, object, or something of that nature. And you can create a string, or you can create a string by appending a string to a particular string that is associated with the kind of class it comes back with or something like that. Anyway. So we have this method testing technique that uses the SEL selector. There's a special @selector directive that turns the name of the method into a selector. So if object responds to selector, shoot, that means the method is in there. So the @selector is a way of testing out to make sure that to test to see if the object actually contains the method, and it comes back and it tells us it's another compiler directive. It tells us if the method is associated with a particular class of object and whether or not the method actually responds. So CEL in this case is an Objective-C type for a selector. SEL. So sometimes you'll see SEL, sometimes you'll see @selector. Did not put @selector on the final exam. I have in the past, however, which is why it's part of this. I write a new exam each term. I did ask questions on this the last time. Most of the students did not pass this part of it. So I didn't put it on yours. So it's kind of something we don't really work with very much in the course and haven't really worked with in this particular course, which is why I sort of left it out, actually. Each section of the class I focus on different areas. So okay. So let's see. This one's using it to make sure that or down here for a UI button, add to target ID, and action, and then we're going to select, use SEL for the action. So that's part of the parameter. Okay, this part is on the final exam, and it's the foundation framework I talked about before. So Nsobject, and my speaker thing is not working so well, so you guys are going to need to be a little bit more quieter. Okay, good. We're almost done with the lecture for today, so don't make it last any longer than it needs to. Here's the foundation network, a framework, excuse me. Framework foundation. There are at least one question on this. So Nsobject, the base class for pretty much everything you're going to have in iOS, and also very important in terms of foundational concept, implements introspective methods, has a bunch of other stuff built into it. It's all part of NS framework, or excuse me, framework, I should say, that's going to be called foundation. And so we have a NS description, useful method for overriding its at or log, percentage at, which is in NS log. So we have a couple methods here, copy and mutable copy. Copy, not all objects implement the mechanism, not all ones implement the other one either. To make copies of objects. So foundation gives us the NS object, gives us the ability to copy objects, assign objects, create mutable objects. Also includes everything with NS in front of it. So NS string is an example, and NS mutable string. So NS string, any language uses a string, uses Unicode. Used throughout iOS instead of the C language character, the character with the asterisk. So if I ask you to create a string on the final exam, you're going to create an NS string if you're creating a string that is compatible with Objective-C. You're not going to use this character pointer. That would be a C-style way of doing a string. So the compiler will create an NS string for you this way. So use the at directive to tell the compiler we want to create a string. The at directive works because string is the default value. So this is a string. The data type NS string is a default value from the framework. We're only including or importing in the framework, the foundation framework. And that one has already predefined NS string for us, so we get an NS string out of it by default. So we don't have to say convert to string or something. We just say at, and then we give it a string, and it makes a string for us. So an NS string instance cannot be modified. It is immutable. So it actually is kind of interesting. An NS string instance is not modifiable. It is not modified. It's immutable. Usual pattern is to send a message to an NS string, and it will return a new string for you. You just keep creating new strings from it. So self.display.text equals self.display.text, string by appending string, colon digit. Creates a string by using those digits and appending them together to create a string, returns a string. Or a string with format at G with a brain operand. So it's going to give us the method property, the object property, and put it in there for a string with format. As an example, that's a CG point actually, or something. I don't remember what data type that is, but tons of utility functions that are used for tons of utility string functions that are used for conversion. You do not need to know any of these for the final. I'm not going to ask you to regurgitate all of the string methods there are to create a string. But know that you can create a string from using another data component that's not a string. But you're not going to be asked to write one. That's what I'm saying. That would be above and beyond the call of trying to remember something for an exam. We also have an NS mutable string. The mutable concept is on the final. So mutable meaning that it can change. We've seen them with arrays, we've seen them with strings. Most of the data types come in mutable form or non-mutable. The default is the non-mutable. Mutable means it changes, it can grow in size. Mutable versions of NS strings exist, exactly rarely used, however. You can do the same thing with string, but you can do without creating a new one in place changes. So create a string. You want to have it assigned to another string, well, you create another string, and you just keep creating more strings and more strings and more strings, and you just keep assigning them to each other. The old strings that you're not using are getting garbage collected. So it's not as if they're not changeable, they are changeable. A string can have this string assigned to it, and then a string can have another string assigned to it. Every time you make a new assignment of a string, you're creating a new string. That's why it's not mutable. It's immutable. It doesn't change, you just create a new string. You don't want to create a new string, you can use a mutable string and just change the current string to a different string. So you create a different value for the current string. What's the sense in that? There's no sense in that. Hardly ever used. Why would you even want to? It doesn't take up that, strings don't take up that much memory. So by default, and that's kind of a tricky question actually, the mutable version of it in this particular case makes absolutely no sense, because you're creating new string assignments with new strings. You're just creating strings over and over again, and they reside at different memory addresses, all those strings. The mutable string, it's at the same memory address, and it's the same string, it just keeps getting recycled. No, there's no benefit to it. However, that's different from a mutable array. An array, you want to keep those elements. You're not replacing the string. You hopefully want to keep the elements that are in the array, and you just want to grow the array. Mutable arrays make more sense, actually, because then you can expand or shrink the array and conserve the memory and retain the value. But strings just keep getting replaced over and over again. So it's an interesting concept, actually. So you can do whatever you can do with an NSString, you can do with a mutable one in place. And the mutable one is actually created the same way. Then we have NSNumber. NSNumber is an object wrapper around a primitive. And the primitives that we are looking at is a float, a double, a boolean, an integer. So NSNumber, and we have the pointer number, it's going to be equal to a new NSNumber, number with integer, just like string with digits or string with value of something. We can create a number with integer, and we gave it 36 and it gives us the number 36. Because we still have to make 36 into a number, although it is a number. Just the same way we had to make the string into a string, even though it was a string, which is kind of an interesting concept. And then we have a way of using it. You know, float f is going to be equal to a new number float value, which is going to be, you know, that's a float value of a number. So you're running a method here. Would return 36 as a float if you converted it, because number's here, so we can convert a float value. So this is an object, this is a primitive. We can go back and forth between the objects and the primitives. We have to convert the value of the object to its proper type before we use it, just like we do a string. Then we have NSValue. It's a generic object wrapper for a non-object data type. It's a value type, non-object type. So CG point here is a point, and then we have a value. So NSValue here, point object is going to be equal to the NSValue of the value with the CG point. So it's an NSValue, not an object. It's just it's a generic object wrapper. Actually, it's just a value being stored. NSData is a bag of bits used to transmit data for iOS. It's generic data format, actually. You just want to create data bits, or bytes, I should say. And you're going to pass data back and forth for networking, for UDP, TCP applications. Comes in handy for a lot of things. We actually used NSData as a data type for one of the projects that we put together, actually. NSDate's a no-brainer. We did that one. It's another date-time format. Holds also see NSCalendar, NSDate formatter, NSDate components, which we all looked at. We've looked at already in a couple of different tutorials. Here's our NSArray. Our NSArray is an ordered collection of objects as an array object. It's immutable. So once you create an array, you can't add or remove objects to it. So we have an NSMutable array that works with it. So the array is the array. It doesn't change unless you assign it a new array value. My mic is no longer working, and you guys are too loud. Thank you. I can't yell over you. My mic is not working anymore. The battery ran out. Okay. So NSArray versus NSMutable array. In the NSArray object here, we have a little method, and this is a class method because of the plus. Array with objects, where we're going to create objects and we're going to stick it in an array. You guys actually did this in a couple of your assignments. In fact, the array of ships is a good way of doing this one here, where we have NSArray. I mean, this is one here is going to be primary colors, which is going to be an array with objects red, white, blue, yellow, whatever. So it loads objects in. We can have a count method, we can get the last object, we can get the object at an index. We have a bunch of methods that we can run on this, and it works just fine. The objects don't change. You cannot add or remove objects from this array. You want to add and remove objects, then you create an NS mutable array. In this form of the object, its mutable version, it changes. In no other programming language do you actually have this much pairing between mutable and non-mutable objects, and so much interchangeability actually. You can take an array, an NS array, turn it into an NS mutable array, change the objects, and put it back into an NS array just by doing a type conversion on it. So, some people just use it as a mutable array. If you want to use it as a mutable array, then you're going to end up accidentally changing it probably. Maybe. It depends on what you're doing with it in terms of why you would do it. So don't forget that NS mutable array inherits from NS array's methods, count, object at, so you get everything. So mutable is a step above the regular array. So you still have all of the regular array stuff in there. Some of you might be familiar with Nsdictionary. So we have data structures that are kind of built in here. We have some abstract data types like a dictionary that works like a hash. So it's a mutable, immutable hash table. Look up objects such as key and a value. And so we have dictionaries with objects and keys. We have the count. Well, it comes from an array. So keys are set and they're hashed by the unique identifications. Keys have to be unique, the values can change. And this object returns an object's pointer at its hash and is equal only if the pointers are equal. And the keys are often NS strings actually. We also have the NS Mutable Dictionary. So for an NS dictionary and then an NS Mutable Dictionary, NS Mutable Dictionary creates an empty dictionary that can be used. NS Set. No, and lo and behold, NS Mutable Set. So these all come in different pairs, as I was mentioning before. I'm not going to go through all of them. I'm just giving you a sampling here. But these are the most common ones being used. The set, immutable, unordered collection of distinct objects. For those people in the data structures class, you know what a set is, you know what a map is, you know what a dictionary is, hopefully. If not, you better know soon for the final. Mutable version is the NS mutable set. And we have NS ordered set. Actually, I should have taught the data structures course with Objective-C. I think that would have been interesting. Taught it with Java last term. So anyway, if you take the data structures course, it's all about Java data structures because all of the collections package, it's easier to use data structures in Java. But now I'm thinking about it, I'm looking at this going, hey, I probably could have done it in Objective-C. But half the people don't have MacBooks, so it's really complicated. You're not going to program in an Objective-C unless you have a MacBook, and half the people who take data structures class barely have Windows computers. So anyway, foundational framework here for an NS ordered set. Again, you've got a NS mutable ordered set. So we have enumerations in Objective-C as well, looping through items of a collection in an efficient way. So it supports the for-in. So we have an NS array of NS string objects, and then we can say for this one and in this one, do something with each one of the objects. So it enumerates. So we can loop through the keys and the values of a dictionary. So we have an Nsdictionary, my dictionary. For the ID in the dictionary, do a bunch of stuff. So most people have probably not used the for in, or the in this key, do something kind of syntax, but it's another form of looping that not supported in C++ or Java, but it is supported in Objective-C. Lo and behold, we have the property list terminology. The term property list just means a collection. So it's a collection of collections, specifically in a graph or object containing only the following classes. And we have NS array, NS dictionary, NS number, NS string, NS date, NS data. Remember the property list? We actually had a project that created and used property lists. I don't believe I asked you any property list questions though on the exam. I don't think I put anything about property lists on there. I probably should have. I left that one out as well. That one and the other topic I told you earlier about. But in any case, they come in handy. They're just collections of data points. Remember, I think we did one for first name, last name, telephone number. So I think it was for an address book or something. And then you can copy the plist file, which is property list. You can copy it to the phone. You can have it created on the phone, modify it, add and write, read and write to it from the SD card and stuff. So an NSArray is a property list, and if all of its members are so if all of its members are a property list. So anyway, NSArray is an NSstring, NSArray of NSarrays. So Nsdictionary, only if the keys are properties. So long story short, property lists are kind of useful. However, I didn't put them on the exam, so it's not. No one's actually going to look at it. Other foundational components, NS user defaults. So lightweight storage of property lists. We actually didn't do this because it's kind of outdated right now. In fact, not all of the project types actually support it. So it's something that is hardly used because it can be done. You can actually accomplish the same functionality in a lot of different ways without doing it this way. In fact, property lists really aren't used that much either anymore. They used to be used a lot more actually in the past. But certain things have been phased out actually from the iOS platform and development stuff. So anyway, that is the last slide of this lecture, and that's the end of part two of part two of the review lecture of the items that are going to be on the final exam. This is kind of a run through. We don't have very much from the end of it, so most of it's from the part one of what I just went over. We have a couple of other items to take a look at, and it's the view controller and the model view controller syntax. So I'm going to push forward a little bit here, go for another 20 minutes or so, and then we'll take another break. But I wanted to, because you do have questions about multiple choice question that involves a view controller, but it's really part of model view controller. So you have an essay question on model view controller, actually, which is why I wanted to give you a little bit more information on that concept. So we know the view, that's the window, and the view controller is the class object that controls the window. We know that part, right? And we know that the model view controller has data, model, which is the model, the data model, and the view and the controller, which is where we get the MVC from. So those are the three parts. Not a bad idea to be familiar with the three parts, actually. So hopefully you're pretty good at handling the basis of putting one of these together. You can actually have model view controllers working together and multiple model view controllers in one app. What does that mean? So for each one of your views, you create a new view controller and you have a new data model. Or you share a data model among all of the different controllers. So there's a couple of different schools of thought on that. The model view controller design pattern originally has separate data, separate views, separate controllers per each component, and you put all the components together and stick them inside the app. So it's slightly different syntax. I have actually I have a little bit more on this that I'll share with you tomorrow morning, because we still have tomorrow morning as a lecture part. So I'm going to give you the first half of the view controller stuff. I'll do this lecture today, and then we'll do the other parts with the source code examples tomorrow morning. Because I want to give you some time this afternoon to study and finish up projects and stuff. Ideally, you should have everything done by tonight or tomorrow night at the latest. Don't wait till Monday to do this stuff if you haven't turned it in yet, because it's way too late for you at that point. Alright, so your model view controller runs in groupings. Model view controller groupings, mentioned it before. What happens when your application gets more features to it? You add more groupings. So not all your UIs can fit in one model view controller or view, so you have to change the three components around. So here we have two of them working together. So we never have a model view controller view span access across screens. Each screen has its own controller, its own view, its own model. So you've created a new one. So your screen shouldn't have multiple classes. Your screen being your view shouldn't work with multiple controllers, only be one controller. Which is why when you create the new controllers or the new subclasses, you get a view that comes with it, or you get a check mark that says, do you want to put a view on there? Some people like to create the views separately, some people like to create them all together, and they create the objects themselves. So you have to switch back and forth between the different model view controllers, and they'll run in a little baby set on their own. So they work together, and here's an example here where you have a UI navigation controller, and it's for the navigation bar on the top as an example. And then you have separate controllers inside for the other components that are in the window. So these are the controllers of controllers. So we actually have some controllers of controller project types, like the tab view controller. So we have tab view projects, we have storyboard, enabled multiple view projects, different configurations of this that are just higher up in the hierarchy because they're controllers of controllers, as an example. So this is the way the design pattern works. So the UI navigation controller is a controller whose view looks sort of like this in this particular case. So we have multiple ones working together, and then we have this root view controller. So root view controller can be used to control the sub-model view controllers. So you got 5 or 6, that's the storyboard in essence. When you start looking at the concept, you have a root view that's controlling all of the subviews, and the subviews are views. And so you have a controller of the controllers, call it a root view controller, and then you got a storyboard. And it's embeds that the model view controller view is inside of its own view. So just showing you the design pattern. So you put a button in a view, and you can sequin it to other views. Remember, we sequined in a storyboard example we did last, it was November 10th weekend, or 9th or 10th weekend, I think it was actually, where we clicked on one and you connect it to another view. So the view goes to another view. We did this, and then we push it, or we modal it, or something. It just basically tells us how we're going to translate over to the view. So we pass views. We pass between the model view controller sets by going from one model view controller set to another model view controller set to another one, either within the set itself or by a root view controller. So if you put in a tab view controller, which is root view controller, you have tabs on the bottom. And the root view controller is embedded inside those tabs. And each one of them is switching to a different model view controller. Or the sequence, which goes from one model view controller to another model view controller with 3 different options to create the relationship. The relationship is created by a push. One pushes to the other, passes data, the other one modals. Take this one, pop it out, put the other one in. Or sequin it so one flips or one does a special behavior. If you play around with it, you'll see what I'm talking about. We did this actually during the last weekend meeting of this class. Alright, so those are the model view controllers working together. If you thumb through this one, and this one is called View Controller 1. Here's our segues, can't say that word right. Talk about how segues get set up first. Well, here we go. Here's a picture of it if you missed that lecture. So you put a button, let's say for example on the first view controller, click on the button, right mouse click on it, by pressing the control button it brings up a little screen. This screenshot is going to show you the old menu. The menu actually changed a little bit. So to create a sequin, you hold down the control button and you drag it over and you highlight this view controller. And when you do that, it kind of looks like this. You got an arrow, and then you got this little connection that goes in between. These are the model view controllers connecting themselves together. And then you click on here, this little guy in the middle brings up a little menu. So the sequin will be created. This is the sequin that gets created. I don't know why they call it that, but in any case, you have an identifier over here, and this is where you can change it to push it, to modal it. There, we have a little window that pops up now where we can select the relationship right through the window without having to use the properties on the side. This is an old screenshot. So the push, the modal, or the custom are the 3 options actually. Basically, when you press the button, this window goes away, or it gets pushed to this one, or some custom behavior occurs. So you're switching between the model view controllers, which is the concept. So, and then we can set the initial view controller, resize the view controller, or the nib. Actually, these options got moved around as well, but they're on the view controllers. So you can click on the view controller, go over to the right properties, attribute inspector, change the properties of the view controllers as well. That creates a little more interaction or a different look and feel. So you can also tell app delegate which view controller to load first, which one's going to be the root view controller. And the root view controller is going to be the starting view. So most people run into problems when they create multiple view controllers with multiple views, and then they forget to tell the app delegate which one to load as the root. So you have this beautifully running application, but it never shows up. Instead, you have this other view controller that's showing up. Or you've got views that aren't connected to the view controllers correctly, or something of that nature. So this is really an iOS programming concept, not necessarily an Objective-C one, which is why I sort of saved it for last to kind of throw it in. But we did look at this. We don't actually have any questions regarding iOS application development. It's all Objective-C. But we do have a question about model view controller. This is giving you the big picture on the view controllers. So, and using the model view controllers together. So now you see we have 3 of them together. So, in terms of the UI navigation controller, it's another controller of a controller. So I have a UI view that's obtained from a view property. And the UI view controller most likely is pushed by the root. So here's one that does Gmail as an example. That you can actually, in fact, the Gmail app actually, the mail app actually is a UI navigation controller on a mail client. So, and then we have a name here for a navigation controller for the top bar, menu controller. So, and a bottom bar as well. So let's see. Nothing really much in this lecture you're going to need. This is sort of the, if you are continuing onward, the next course after this course is the iPhone or iOS application development course. That one's actually being taught on Mondays next quarter, if you're local to the campus, where we'll get into aspects in terms of view controllers, and we basically create more root controllers, and we create better and more sophisticated view controllers, and we use those together. So I leave you with that topic, actually. There is one project that you can download called Psychiatrist, actually. And if you load this guy in, I'm going to load this one. This is called viewcontroller1.zip. I'm going to finish this tomorrow, but I just wanted to show you what this one looks like. If you're interested, you get bored, you want to play with something. This one is an old 6.1 iOS project format. It should still run. If I run it, I was going to run it on an iPad. Oh well, it's not exactly what I wanted. I might have to switch it over to an iPhone. Oh, here it goes. So you see the default view controller that loads up by app delegate, and you have a button over here that switches and puts up another view controller with another view. So you have multiple sets of model view controllers working together, and the buttons are giving you the segues. So it's changing. This one here is changing. This view controller is changing this view controller. So it's pushing information back and forth. So when you get past the beginning development stuff, and you start working with more sophisticated app designs, and you start working with model view controllers a little bit more, because that's how you're going to get your better interactivity. So anyway, you can play around with that one. You might actually find that one interesting to take a look at. There's no tutorial for it. It's just put up as an example. Okay, so I'm going to stop this part of it, because what I did is I pretty much finished the review section, and I finished the introduction to model view controller, which is really all you need. Is the basic concept of what model view controller actually is. So let me stop this recording.